Okay, picture this. Food that actually changes after you've made it. Pasta that tells you when it's perfectly cooked. Or get this, smart labels that warn you the second your fruit starts to spoil. It all sounds a little bit like science fiction, right? Well, today we're going to dive into how artificial intelligence is making all of this a reality.
I mean, seriously, just think about that for a second. We're not talking about it just getting cold or stale. We're talking about food that's designed to intentionally transform its shape, its texture, maybe even its nutritional value, all on its own. This one single idea is launching a whole new revolutionary field.
And that field is called 4D food printing. You've heard of 3D printing, of course. Well, this just adds a fourth dimension to the mix, and that dimension is time. So these are dynamic, edible structures that are literally programmed to change in a very specific way when they hit a certain trigger.
So how does this all work? It's actually a brilliantly simple three-part framework. First, you need smart base materials, things like proteins or special polysaccharides that can act as a functional base. Second, you need some kind of external trigger, like a change in heat or humidity or even pH. And third, you get this really innovative response, like the food morphing its shape or changing its color or releasing nutrients right when you need them.
Now, this all sounds pretty amazing, I know, but there's a huge challenge. And surprisingly, the hardest part isn't the fancy printer or the complicated shapes. No, it's what happens before you even press the print button. The single biggest point of failure is the food ink itself. Trying to create a stable, predictable, and totally safe ink with complex food ingredients, well, it's an absolute minefield for food scientists.
And the challenges are coming from all sides. Your ingredients can react in totally unexpected ways, leading to chemical problems or just degrading entirely. The ink might not flow properly. That's a whole science known as rheology, which, is pretty critical for printing. And of course, these nutrient-rich inks can be a perfect breeding ground for microbes if you're not super careful.
So, you end up stuck in this dilemma. Your perfect ink needs to be thin enough to flow smoothly through a tiny little nozzle, but it also has to be strong enough to hold a complex shape the second it comes out. If you get it wrong, you're just left with clogged printers, sad collapsed food blobs, and worst of all, potentially unsafe products.
So how in the world do you solve a problem that has millions of variables and totally unpredictable interactions? Well, you bring in a secret ingredient. A new kind of chef, if you will. Artificial intelligence.
But here's the key thing. The AI isn't driving the printer itself. Its most important job is actually in that pre-printing phase. It's acting like a master digital food scientist, analyzing all the variables and predicting how an ink is going to behave before a single drop is even wasted. This totally shifts the process from, reactive troubleshooting to proactive design. But how does it actually do that? I mean, how can a machine possibly know that two ingredients, which are perfectly fine on their own, are going to create a total disaster when you mix them together?
Well, here's how it works in practice. AI models, like something called an artificial neural network, or ANN, they're trained on huge amounts of chemical data. You input your proposed recipe, the ingredients, the pH, all of it, and the AI predicts the risk of things like lipid oxidation or protein denaturation. It basically flags bad combinations before they're ever mixed.
Okay, so AI can predict chemical reactions. That's cool. But what about that physical problem? Making sure the ink flows correctly but doesn't just collapse into a puddle.
This is where AI-powered rheology comes in, and it's a real game changer. Instead of just messy trial and error, which, as you can see, might give you a collapsed structure a lot of the time, AI can analyze the properties of the ingredients and predict the final shape's integrity with incredible accuracy. It lets scientists design formulas that are pretty much guaranteed to hold their shape.
So that's all the theory, but let's look at what this technology is already making possible. I mean, these aren't just far-off concepts. These are real examples coming out of food science labs right now.
First up, a smart food safety indicator. Imagine a simple label that can visually tell you in real time if the fruit in the package is starting to go bad.
Here's how they did it. Scientists 4D printed a label using a smart material, in this case something from blueberries called anthocyanin. The trigger is the change in pH that naturally happens as a kiwi spoils. In response, that anthocyanin in the label visibly changes color, giving you this clear, immediate warning that the fruit is no longer fresh. How cool is that?
All right, let's look at another one, something maybe a little closer to our dinner plates. We have all been there. Is the pasta perfectly al dente, or is it just mush? Well, what if the pasta itself could just tell you?
To solve this age-old problem, researchers created a 4D printed pasta that's infused with red cabbage juice. The trigger is simple, just cooking it in hot water. As it cooks, the pasta actually changes color, giving you a built-in visual cue for when it's perfectly done. No more guesswork.
These examples are absolutely incredible, but they're really just the beginning. The next step is to make this whole AI-powered design process even more sophisticated by giving it senses that mimic our own.
Yep, you heard me right. The next frontier is to move beyond just predicting physical and chemical properties and to actually give the AI a sense of taste and smell by using some really advanced sensors.
This is done with two key tools. First, the electronic nose, or e-nose, which can literally smell the food ink. It detects these volatile compounds that might signal spoilage way early. Then there's the electronic tongue, or e-tongue, which can taste the ink by monitoring things like proteins and ions to find any instabilities in the formula. All this data gives the AI a level of insight that's just unprecedented.
But, and this is a really important point, this is not about replacing human scientists. As the researchers themselves state, the future is all about these hybrid frameworks. AI is an incredibly powerful tool that's meant to complement human expertise in food chemistry and engineering, basically amplifying what they can achieve.
Because ultimately, the end goal of all this complex science isn't just to create flashy, innovative foods. The goal is to create trustworthy food, products that are safe, that are reliable, and that behave exactly the way they're designed to every single time.
This technology opens up this whole world of possibilities, from personalized nutrition that releases vitamins at the perfect time to foods that can adapt to our specific dietary needs. It really just leaves us with one final, exciting question to think about. With tools like these, what kind of smart food would you design?